Right, here we go. Let's do it. First one.
So this motion sensor data didn't come out very well, but we can start by drawing our line right here, which represents the instant when we let go of the cart. So that's t equals 0. And it took a little bit under a second for the cart to reach the end of the ramp, so we'll say 0.9 seconds. That means that on our motion map over here, each dot is going to represent 0.3 seconds. We're going to put our first dot here at the starting position, and we know that our object is starting at rest, so it's going to start off slowly. So our second dot will go there, and our third dot is a little bit faster, fourth dot a little bit further along, and then we're going to draw our arrows to show that the object is picking up speed. Is the velocity positive or negative? Well, we know that the cart is going in the positive direction, so the velocity is positive. Now, to draw the acceleration vectors, let's think about what's making this cart go down the ramp. Well, the cart is feeling the effects of gravity pulling it towards the center of the earth. But since there's a ramp in between, the cart is just following the path of the ramp in the positive direction. So it's accelerating in the positive direction. Therefore, the acceleration is positive, and all of these little vectors underneath are going to be in the positive direction. This shows you that when the velocity is positive and the acceleration is positive, the object is speeding up. Now let's look at our graphs. So here on the position graph, you see that there's a slight curve, and the slope of that curve is increasing. It's getting steeper and steeper. So I'm going to write that the slope of the position time graph is increasing and positive, and represents velocity. Now the velocity time graph should really be straight. I don't know why there's this little piece here. Maybe I inadvertently guided the cart down the ramp with my hand a little bit. So the slope of the velocity time graph should be constant and positive and represents acceleration. And a constant positive acceleration should not give us this lump here. It should be a nice straight line. So this is what your stacks of graphs should look like for scenario 1. For scenario 2, the motion sensor data is a lot better. And just like in the last problem, we're going to set our time, and we're going to set it right after the initial push. So right there where you see it starts off with an initial velocity. Our motion map starts at the initial position 0, and it starts off going fast. So we're going to put our first dot a little bit further down, and as it goes along the ramp, it starts to slow down until it comes to a full stop. Let's put in our arrows to show that the velocity is decreasing. Is the velocity positive or negative? Yes, it's still positive. Even though it's slowing down, it's still going in the positive direction. Is the acceleration positive or negative? Well, the acceleration is still down the ramp this way. So that means you have a negative acceleration, and that's why the cart is slowing down. And your acceleration vectors should be pointing in the opposite direction. Now let's look at the slope of the position time graph. So the slope is still positive, but you can tell that it's decreasing, right? It's getting less and less steep. Now notice that even though the velocity is positive, its slope is negative and constant. And then it comes to a full stop here at 0, which means that its acceleration is negative. So this is what your stacks of graphs should look like. So in the third scenario, we got perfect motion sensor data, so we don't need to change anything. On our motion map, our starting position is starting away from the motion sensor. So we'll put our first dot here with the cart at rest. Then it starts rolling down the ramp, so the next dot goes here. It picks up a little more speed, next dot is here, and then finally it reaches the motion sensor at the starting position here. Is the velocity positive or negative? It is going in the negative direction, so the velocity is negative. Is the acceleration positive or negative? Same thing, since the direction down the ramp is heading towards the motion sensor, or towards the starting position, then the acceleration is negative. And as you can see when you draw your acceleration vectors, if the velocity and the acceleration are both negative, then the object is speeding up. Now let's fill out our graph. The slope of the position time graph is increasing, it's getting steeper and negative. The slope of the velocity time graph is constant and negative, which means that the acceleration is going to be a horizontal line here in the negative part of the graph. And that's what your graphs should look like. Alright class, you can now finish the rest yourselves. Scenarios 4, 5, and 6, I gave you the raw data that Peter and I collected, and it's up to you to just fill out the rest of the worksheet, and especially section F with the graphs. One of the key things to remember from this lesson is that if the velocity and the acceleration are both positive, or if the velocity and the acceleration are both negative, then the object is speeding up. If the velocity and the acceleration are in opposite directions, then the object is slowing down. Feel free to pause the video anytime, and don't forget to check out the blooper reel at the end.